Hey, chemistry nerds. I've got an addition here to the History of the Atom screencast that I uploaded earlier. Focus a little more on Thomson and Rutherford. I know that their experiments and how their results led to changes in the previous models of the atom has always been a bit of a sticky point for students in the past. So I thought if I came up with a visual to go along with that, that might be of some assistance. So let's give it a run. I set up this animation in PowerPoint with no audio, so sort of had to set up all the timings there. So I'm going to cross my fingers that I read the script that I made for myself in the same sort of way as when I time the animations, and I don't get too out of sync with myself here. So wish me luck, and we'll get started. I'm going to start off with Dalton's model of the atom. And Dalton believed that the atom was indivisible, so I've just represented it here with a solid sphere, no parts. Later, Thomson discovers that the atom actually has a negative part, which he calls the electron, and this means that there also must be a positive part to the atom. But he doesn't know much about that. What he does know is that the negative part has very, very little mass for its charge. So he represents that as a very small, dense region of negative charge. This means that the rest of the mass of the atom must be this positive charge, so its charge will be large and spread out and very kind of weak. Rutherford tries to back up this, and he designs an experiment knowing that opposites attract and like charges repel. So if the positive charge is all big and weak and spread out, if he fires alpha particles, which he knows to be small and positive, at this kind of weak positive charge, they shouldn't be repelled too much. They should just plow straight through with maybe small amounts of deflection, but mostly unaffected. His results, though, didn't back this up. Most of the alpha particles made it straight through completely unaffected. However, about 1 in 8,000 would come flying straight back at him. He said it was as if he fired a cannonball at a piece of tissue paper and the cannonball ricocheted. He concluded that the positive charge, though indeed most of the atom's mass, is actually very tiny, and he called it a nucleus. The reason so many alpha particles were unaffected is they just missed this small nucleus, but the 1 in 8,000 that sort of randomly hit it were strongly repelled and bounced back. So, I hope this visual helps you guys understand their experiments and how they changed the previous model a little better than just talking about it. I'm sorry I was a little rushed, like I said, just reading from a script, trying to keep up with my timings from the PowerPoint that I made. And I would love to know if this video was a little more instructive for you guys and helps you nail that short answer question on the test. Thanks, and talk to you later.